So wanted to start by saying thank you to the organizers of DroidCon. It's great that you pulled this off. I know it hasn't been easy, and there's a lot of talent in Madrid and the rest of Spain, so I think this is not only deserved, but also needed by the community. So thank you guys very much for this. All right. So today we're going to talk about architecture, reactive UIs, LiveData with coroutines, LiveData with flow. So we have a lot to cover, but we have 45 minutes. So, well, first of all, who is not familiar with LiveData? That's like 5%. OK, doesn't matter. I'm not going to change any of my content. I'm just curious. So let's start with a little bit of history. And we cannot talk about Android architecture history without this post by Diane Hackborn. She's the Android framework team lead. She has the coolest last name here, better. Coolest last name ever. And this post was very controversial because basically she was saying that they were working on creating a solid, reliable, fast, secure framework, but that they didn't care about what was on the other side of the API, basically your apps. It was controversial because you know Reddit. What she meant was that the framework team was never going to give you an opinion on how to create apps. Obviously, this didn't mean that Google didn't care about architecture. We actually had architectural samples, and we were talking about releasing this thing called Android architecture components. And the reality is that there are millions of developers out there, millions. So the ones that you see at conferences, that you read on Medium or on Twitter, they're the ones that have interest and time to tinker around, to create their own architectures, or to do research on new patterns. But the vast majority of the people, this is a stat that I completely made up, of course, they're just looking for best practices. And that's why we released architecture components, which obviously is a collection of libraries. We released this in 2017. And one part of it was the actual library. So we released in Alpha 1 LiveData, ViewModel, an early version of Room. But I think more importantly, for the first time, we were opinionated on how to create things. And this was just an opinion. If the framework says how to do something, you have to do it. But this, for the first time, was just, if you want, you can use these patterns here. But if you don't, that's fine. Obviously, this doesn't apply to the Facebooks, the Ubers, Airbnbs, etc. But for the vast majority of the people, this was welcome. All right, so the first component I want to talk about very briefly is ViewModel. We actually released these components because we needed them for the guide to app architecture. And we needed an object that would survive something very important in Android, which is configuration changes. You know that if you rotate a device, the view, activity, or fragment is destroyed. And then it's recreated again. So we needed an object that would survive this configuration change. Now, this is the ViewModel scope diagram. In here, you see an activity being recreated. So there's a device rotation. The activity is destroyed. Then it's created again. As you can see, the ViewModel doesn't receive any callbacks during this creation or this recreation until the activity is finished for good, in which it gets a callback. It gets a call on the uncleared lifecycle callback. That's all it does. All right, so now that we know about ViewModel, we can start talking about LiveData. And very quickly, LiveData is a simple lifecycle aware observable data holder. All these things. So let's start by explaining the first one, which is observable. In our object-oriented world, probably the easiest way to communicate one component with another, one object with another, is by just having a reference from one object to another. You can inject this reference, you can create this object here, whatever. The thing is that once you have a reference, you can communicate. You can call the accessible properties and methods. But doing this in Android is a little bit risky. You might probably see the snippet and get nervous. What's going on here? We're injecting an activity into a ViewModel. As we saw before, the ViewModel has a larger scope than the activity. And actually, when I say that the activity is recreated, I mean the class. But there are actually different instances. So if you pass the reference to activity number 1 to the ViewModel in creation, after the rotation, what's happening? It's a memory leak by the book. Also, it's very dangerous because if you try to access this first activity after the rotation, in Java, you might get a null pointer exception. In Kotlin, nothing will happen probably, which is even worse than a crash. So instead of having a reference to the activity in the ViewModel, we're going to have a reference to the ViewModel in the activity. And then you might think, OK, how do I send data from the ViewModel to the activity? That's what the ViewModel is going to do 90% of the time. So instead of doing this, we're going to observe data. This is much safer. Let's see the big picture here. Oh, by the way, there's a green rectangle there. There you go. So this is the big picture. A view, an activity, or a fragment comes in. It obtains a ViewModel that is created in this case. And the ViewModel exposes LiveData. It can be one LiveData or multiple ones. In onCreate, this activity is going to subscribe to these LiveDatas. It's going to create one or multiple subscriptions. Now there's a configuration change. This activity is destroyed. And another instance comes along and subscribes again. This is the safer way to do this communication between view and ViewModel. And by the way, this subscription is destroyed automatically. And that's the whole point of this presentation, by the way. So how does this look like in code? We have a ViewModel that is exposing a LiveData. We call that my observable. As you can see, LiveData is just a holder of data. So you can put there whatever you want. You can put a string. You can put your own thing. In the activity, we obtain the ViewModel somehow. Again, I'm not going to explain how to do it right now. In the documentation, you can see how to obtain that ViewModel. It can be tricky if you want to pass parameters. But the important thing is that in onCreate, you create your subscription. And you do that by calling observe on the observable that is in the ViewModel. The first parameter of this observe method is a lifecycle owner. And this is going to define the scope of that subscription, when that subscription is automatically going to be destroyed, and some other things. The second parameter is the observer. The observer is going to receive updates to this LiveData. So inside the observer, you can do whatever you want because you're inside the activity already. So you can find view by ID, although this is not modern. You should use a view binding or data binding instead of doing that. But for the sample sake, that's the easiest way to see it. All right. Second feature of LiveData is that it's Lifecycle Aware, and this is what makes it different from another observers. What do we mean by this? So I said that subscriptions are automatically destroyed when the life cycle or the lifespan of that lifecycle owner is done. But also, LiveData is only going to push updates to the observers when the lifecycle owner is in an active state. So what do we mean by this? What's an active state for an activity or a fragment? Well, we define that as being in the state of started or resumed. That means that LiveDatas are only going to get updates between the onStart method and right before the onStop method. We're going to see a practical example of this in this section. LiveData is a simple data holder. This means that LiveData is not RxJava. It doesn't work with streams. It doesn't have a buffer. There's no back pressure to think about. It's a very simple data holder. And we're going to see how simple it is with this example. Let's say you are exposing a LiveData in a ViewModel, and this ViewModel is doing some operation. It gets some data from the network, for example, and it emits value A to the live data that is being consumed by this activity. And this activity is now in the started state. Because it's active, it gets the value immediately. Same thing happens if we emit a different value, it gets it immediately. Now what happens if after on stop, it gets a new value, value C? Well, nothing happens because there's no active observer. And what happens if before the activity is recreated, you get a new value? Value C is lost forever. There's no buffer here. LiveData only cares about the latest value because a UI because that's what a UI only cares about. If you need that C value, then you shouldn't be using LiveData. Think about that, okay? What happens if the activity comes back online? It's resumed or started again. You get the latest value immediately. Right? You don't have to wait for a new value to be, because the ViewModel doesn't know about what's going on in the activity. So there's no way for the ViewModel to know, oh, the activity is now active, so I can push the update again. There's no need to do that. Obviously, if you send an update after the last on stop, that value is going to be lost forever as well, which is a good thing. All right, let's look at some code. I show you a LiveData in code briefly, but I haven't really told you how to create one, for example. So LiveData comes in two flavors, a mutable one and an immutable one. And this is a very common pattern. The mutable one is called LiveData, and the mutable one is called mutable LiveData. If you want to expose something from a ViewModel, you should always expose it as immutable, because you don't want other components that have access to this LiveData to modify its value. There's an exception to that, which is two-way data binding, completely different story. So the way you do this is by using a backing property that is private mutable LiveData, and you only expose the LiveData. All right? Now, how do we set a value? We just call setValue on the LiveData in Java. In Kotlin, we can just access the setter directly by calling value. There's another method called postValue that lets you send an update from outside the main thread, but check the documentation if you need to use that, because there might be a race condition that you're not taking into account, but I'm not going to get into that. Now, LiveData dependencies. What happens if you want a LiveData to depend on another LiveData? So the first function that we, or the first helper that we provide for this is transformations map. In here, you can see it being used as an extension function, so you can call map directly on a LiveData. This means that every time user info changes, which is a mutable LiveData here, name and telephone are going to be updated, and only the properties name and phone from that user info are going to be exposed. Right? So this is a very common pattern. Now things get a little bit more complicated if you have a dependency between two LiveDatas and you want to pass parameters. So you might think, okay, maybe I can do this. I mean, this is how I first tried to do it, which is super naive. We get this LiveData from a repository, and we call getUserInfo. That's going to return a LiveData, and we pass a user ID, so it requires a parameter. And we put the result in this userInfo property. We use map to expose name and phone. So far, so good. Everything works. The problem is that on the other side, in the activity, there's a subscription happening, right? And it's subscribing to this userInfo LiveData. So what happens if after that I set the user ID again? So I assign user info to a new LiveData coming from the repository. But what's the error here? LiveData, the observer in the activity is subscribed to the previous LiveData, because you're just changing the reference in the ViewModel. But the activity is not going to know that this reference change happened. So this is wrong. This is not going to work. The way to do it, it's a very common pattern in LiveData, and it's using switch map. Probably the hardest part of the API of LiveData is a switch map. So the way you do it is you put the user ID in a mutable LiveData, or in a LiveData, for that matter. And then you provide a way to change that mutable LiveData. We have a setter here that updates the value. And then what you do is you use switch map. Switch map is a transformation function that is going to return a LiveData, and it's going to require in its body, what we call the transformation function, it's going to require a LiveData. You have to return a LiveData inside this body. So it's perfect because we can return the LiveData coming from the repository, and we can pass this ID. This is the LiveData that the observer is going to, or that the activity is going to subscribe to. And every time the mutable LiveData changes, all the chain is going to be executed, and you're going to get the correct data. This pattern looks a bit awkward. You have to use it 3 or 4 times in order to understand it. But once you do, you can see it everywhere. We're going to use switch map again in another condition with coroutines. There's another, so I said that LiveData comes in 2 flavors. It was a lie. There's actually a third one called mediator LiveData. This basically lets you combine multiple LiveDatas, and it is what the transformations functions use inside. Right. All right, so let's get to the interesting part of the session. This was a little bit boring, but now coroutines make everything fun, right? So, every time you start an operation, any operation, an operation can be something like going to the network, can be something like preparing some text. You have to choose the scope of the operation. You have to choose when that operation is going to be canceled. If you cancel too early, you might have to restart your operation because you need it in the future. If you stop it too late, you might be wasting user resources because you don't need that in memory, for example. So you choose your scope. If you want to scope something to an activity, you can start it in onCreate and stop it on destroy. If you want to scope it to the ViewModel, you can start it anywhere in the init block, for example, and stop it in onCleared. But in reality, in a real app, this is the Android Dev Summit app, there's a lot of scopes. We have different instances of this schedule screen fragment. We have the ViewModel that controls it. We have another screens like the info screen with multiple fragments potentially, the ViewModel. Then we have a main activity, it's ViewModel, and then we have the application scope in case you want to make sure that operation is only canceled when the process is killed. But this is complex to manage, right? There's a lot of scopes. There's potentially a lot of operations happening concurrently. So we need a way to structure this concurrency. And who's going to help with that? Well, obviously, our new best friend, Kotlin, specifically Kotlin coroutines. I'm not going to do an introduction on coroutines. We would need 45 minutes for that. There's a lot of content online doing so. If you have no idea what a coroutine is, think of it for the rest of the conversation, then forget about it. Think about it as a lightweight thread. But that definition is very dangerous. So just for this presentation, okay? So why do we like coroutines? First, because it's very easy to get off the main thread. It's literally one line of code, and it's a safe way to do it. I mean, since API 1, we've tried to do this, right? Async task, loaders. Some people use RxJava just for this. Executor services, our own thread pools. Now with coroutines, it's like, what were we doing, right? And because these features are baked into the language, they require minimal boilerplate. I mean, using suspend functions, if you know about coroutines, you know they're a breeze to use. But most importantly, they have this thing called a structured concurrency, which basically means that your jobs are managed automatically. Although, in reality, there's no magic. the language is going to force you to define that scope. The same way LiveData was forcing you to define a lifecycle owner when we made a subscription, coroutines are going to require a scope to run in. All right, so how do we launch coroutines, given that now we know that we need a scope? All right, so first, what if we want to launch a coroutine that is scoped to a ViewModel so that it's canceled whenever the ViewModel goes away? We have this extension function called ViewModel Scope. You call launch on it, you're inside a coroutine, you're done. You can now call suspend functions. Very easy, and this is something that you are going to use. If you use this all these things, you're going to use it a lot. If you want to scope it to activity or a fragment, you can do the same thing, but now it's called Lifecycle Scope, another extension function that we provide. You call launch, you're done. However, activities and fragments have more features, or Lifecycle Scope has more features, rather. You can scope a coroutine to a specific state. So you can call launch when resume, launch when created, launch when started. That's a very interesting feature, by the way. So if you want to scope something to an application, then you have to think for a second. Does my operation need to complete? Let's say you are a Twitter engineer and you want to send a tweet to a server. Does that have to complete? Well, if the user is offline and they send a tweet and then they open a game and the Twitter process is killed, that tweet is never going to be sent. So instead, you should consider using something like Work Manager, which is going to guarantee that execution. But if you're doing something like cleaning up a local database, that's something that can be scoped to the application. In coroutines, we call that global scope. Because if it doesn't finish, it's fine. You will do it the next time around. OK, so before I show you how to scope a coroutine to ViewModel, but normally you want to do something with the return of that operation, with the result of that operation, right? So how do we mix a ViewModel scope with LiveData? You could do something like this. So as we saw before, this is how you expose LiveData. So we have the mutable version, the immutable version that is exposed. Then we launch a coroutine. And inside, because we're inside a coroutine, we can call suspend functions. Do computation is a suspend function, potentially heavy or potentially long running. So we want that in a coroutine. And with the result, we assign a new value in the mutable LiveData. OK, this is fine, but it's like 6 lines of code, 6, 7, and you probably want to do this like 12, 15, 20 times in your ViewModel. So this is a lot of boilerplate. So we released this thing called the LiveData Coroutine Builder, which makes things much, much easier. So LiveData Builder is going to return an immutable LiveData, so you can expose it in your ViewModels. And inside the body, you are in a coroutine already. So you can call do computation, which is a suspend function. And once you have a result, a value to emit to a LiveData, you call emit on it. That's it. That's how you create the bridge between coroutines and LiveData. Now, what happens if you need parameters in this suspend function? Again, we use switch map. This is the same pattern that we saw before. We put the ID, or the parameter, in a mutable LiveData. We call switch map in that mutable LiveData so that every time the item ID changes, the switch map is called. And then in the body, because we need to return a LiveData, we use this LiveData Coroutine Builder. And inside of it, we are already inside a coroutine. So we can emit the result of a call to a suspend function. 3 lines of code. It looks like a lot, but it's way better than what we had before. If you don't believe me, check the IO app. It's using the old stuff, and the Android Dev Summit app of this year is using this, and it's much, much better. More features of the LiveData Coroutine Builder. You can pass a dispatcher in the constructor. Obviously, you can also call with context in the second line. This is not a big deal. So apart from emit that we already saw, you can call emit source. And emit source is going to make a bridge between two live data. So this is very handy if you want to expose a live data and add an initial loading string or something like that, and then emit all the values from a different data source. It's a very common pattern as well. All right, how do you cancel coroutines? Very easy. You call cancel on a coroutine, well, on a job, right, coming from a launch. But the whole point of this conversation has been about automatic cancellation. So you almost never do this. So what I want to talk about in this section is something different. Cancellation is cooperative. You have to cooperate because Kotlin doesn't know magically how to stop an execution of a coroutine. Let's say you have this infinite loop here, or you want to create an infinite loop. If a coroutine is canceled, that infinite loop is never going to be stopped. You have to do it. And you do it by checking for a property only available inside a coroutine, which is active. So if you have an infinite loop, that's a good thing to put inside the condition. You might think, okay, I've been using coroutines for a while and I've never had to do this. Are you telling me I have lots of operations running around in my app without me knowing? Probably not. The thing is, all the suspending functions in Kotlin X coroutines are cancelable. Delay is one of them. This means that whenever you call delay, that function is going to check for is active. It's going to check if the coroutine is active. And it's going to stop the execution for you. So if you use any of these Kotlin X coroutines functions, you don't have to cooperate, but maybe you should. All right, before going on, we need to make a distinction between one-shot operations and multiple values and receiving multiple values over time. And we're going to see this with an example. This is the Twitter app. And in order to show this data to the user, there's been some one-shot operations happening. For example, downloading the profile picture, the Twitter handle, the tweet itself, the image in the tweet. And because tweets are not editable, you know that you only have to do this once. Someone got the joke. Okay. However, if you keep this screen open, you see that there are two values there, the number of retweets and the number of likes. And those change over time. If you keep the screen open, you see that those numbers change. That's because they are observing data. They're listening for changes somewhere else. They are observers. So what's the big picture of a one-shot operation? As we said before, we use LiveData to communicate view with ViewModel. In the ViewModel, we use the LiveData coroutine builder to make this bridge with coroutines, with suspend functions. In the repository, because we're using suspend functions, we can simply call all the suspend functions in data sources, and that's it. Super easy. With multiple values, however, things get a little bit more complicated because you have to wire everything up. And you can use LiveData for that. We have used LiveData in the past. But LiveData was never designed as a fully fledged reactive streams builder. It's a simple data holder. So doing this is a bit awkward. Luckily, there's something new in Kotlin called flow. And even though, well, the actual interfaces are stable now, but most of the operators are still in experimental. Even though they are in experimental, everyone is super excited about it. It's clearly the future of Kotlin at least. So we're going to see some patterns. We're going to start with a ViewModel, and we're going to compare a ViewModel listening for changes on a LiveData and a ViewModel listening for changes from a flow. All right, so first pattern is you want to emit multiple values. Values coming from a LiveData and being exposed to a view. If you're not doing any transformation, you can just assign one LiveData to another. You're done. In Flow, or from Flow, you could do something like this. You use the LiveData coroutine builder. You fetch the flow from the data source. You call collect. That's how you receive items from a flow. and then you emit every item that you get from the flow. Okay, I'm saying that flow is much better than LiveData, but this is awkward because it's like 3 lines of code to do something super simple. So that's why we provided this extension function called asLiveData that is going to convert any flow to LiveData. So now it's a one-liner, we're fine, we can go on. Same pattern that we already saw. We emit a constant value and then multiple values from a data source. If that's a LiveData, we can use the LiveData coroutine builder, emit an emit source, and we're done. With flow, we could do the same thing. We could convert the flow to a LiveData and use emit and emit source and the LiveData coroutine builder. But in here, we're creating 2 LiveDatas just for this, and it's not very readable. Instead of doing this, we can embrace Flow's API and use this thing called onStart. onStart is going to let us define what happens at the beginning of a collection. Inside that, you call emit, you pass this constant value, and then at the end of the chain, you convert the whole flow to LiveData. Very easy. And this is where flow really, really shines, which is when you want to do a transformation on each item. With LiveData, this is super awkward. First, because you might want to use map, but calling a coroutine from inside the transformation function of a map is a little bit more complicated. So instead, we're going to use switch map again with the LiveData coroutine builder again. Inside the body, we can call this heavy transformation, which is a suspend function, obviously, and emit every value. But this is much better with flow, obviously. So we get the flow. We call map, and because we are in a coroutine context, we can call this suspend function directly, and then at the end of everything, we just convert to LiveData. So that's much, much better. All right, let's look at what happens in a repository if you use flow. We're going to look at that bridge between your view models and your data sources. It can be one data source or multiple ones, obviously. But there's nothing I can tell you there, because each repository might be different, and there's nothing Android about it. You just use the operators and all the APIs available for flow. So you can do things like mapping, combining, you can switch to another thread, you can do things on completion, etc. Data sources, however, are a little bit more tricky because, and we're going to see differences between suspend functions, so one-shot operations, and multiple values that are exposed in flow. So for one-shot operations, if the API that you're using to get your data already supports coroutines like retrofit or room, you don't have to do anything really. You just assign, you just call a suspend function from another suspend function, you're done. However, you might want to convert from callback-based APIs to coroutines. And for that, you have this thing called suspend coroutine. This is part of Kotlin. This builder is going to give us a continuation. And each time we have a new value, we're going to call resume on that continuation, and we're going to pass the result. That's the happy path. The error path is, in the error path, you just call resume with exception. You can pass the error there. Obviously, this API is something that I made up, so I'm defining different listeners. And then once I've defined all the callbacks, I can run the operation. By the way, we're using here suspend cancelable coroutine, which I think is the one that you should always use. I don't see a use case for suspend coroutine. In this case, if the coroutine is canceled before you get a response, then resume is simply going to be ignored. Okay. All right, what happens with flow? Multiple values. You can use the flow builder, but this is in reality something that you don't only use in with fake implementations of a flow or something like that. In this case, we are emitting a different weather condition every couple of seconds. And we don't have to check for is active because we're using delay, as we saw before. Now, what happens if you want to convert that callback-based API to flow? You use something very similar to suspend cancelable coroutine called callback flow. So let's say we have this callback that I made up. It has 3 callbacks: on next value, on API error, and uncompleted. On next value means that there's a new value. So we call offer. This is part of the callback flow API. If there's an error, we close the flow. And if this API supports or knows when there are no more items coming, you can call close as well. After this, you call register on the API so that everything starts. However, if you just do this, this function is going to exit and everything is going to be garbage collected. You have to tell callback flow that it needs to wait for the close from the flow. And this is great because in the body, we have the opportunity to unregister that callback. This part of the API is by far my favorite. In here, I mean, this particular unregistered call is super hard to do with LiveData. So that's why I absolutely love this thing. All right, testing, super important. I'm not going to talk about it because it's so important. We have a full session on it, a very good one by Manu and Sean from the ADS this year. So check it out if you want to know more about testing coroutines. And well, this is a bit awkward because this is a LiveData talk. And with all that I have told you in this presentation, you could actually get rid of LiveData. We have this Lifecycle Scope that has a launch when started coroutine launcher. And that means that this flow or this subscription is going to be already Lifecycle Aware. So instead of exposing a LiveData, you could expose a flow from the ViewModel. That's why we call flow to flow. You call collect on it, and then you're inside the activity. You can do whatever you want. Obviously, this wouldn't work in Java. Obviously, this is using experimental APIs. It wouldn't work in data binding, but I think it's a very interesting thing to take into account. All right, so some resources. We have a lot of things around these topics. We have this amazing series by Sean on coroutines. It's 4 parts. We have the lessons learned from Manu on creating the Android Dev Summit app. We migrated everything from LiveData to Flow using all the experimental APIs, and it went great. I've written a lot of blog posts about LiveData, so check them out. Yeah, a lot of them. Samples. We have the architecture component samples. There is a new LiveData sample that is using the whole LiveData builder, but LiveData is used throughout all the samples. We have the Android architecture component sample, architecture blueprints samples in the new location, which is Android/architecture samples. We also have the IO app that is open source, but especially the Android Dev Summit app that is simpler and is using Flow and all this. We also have Code Labs. This one is the coroutines with Flow and LiveData is brand new. But we also have Android Room with a View in case you want to know in general about architecture components. And one very small code lab called Lifecycle Aware components that touches on LiveData and other features of ViewModel. So that's all I have. If you have any questions, I'll be around in the conference after this. Thank you very much.